Hello and welcome to exercise 6 on page 66 of the workbook. And we'll do this problem in two parts. Let's read part A together. They'd like us to show that all members of the family y equals x cubed plus c over x squared are solutions of the differential equation xy prime equals 5x cubed minus 2y. Okay, now you might read this and think that's sort of a strange choice of words. What do we mean by all members of the family? That's kind of a strange sounding statement. Well, the word family is used because this formula that we have here is actually representing an infinite family of functions. C can be any value. It's an arbitrary constant, and so family is just a way of describing a bunch of functions at once. Okay, what we're actually going to do is no different than what we've done before. It's just asking us to check and see if that function, x cubed plus c over x squared, works in this differential equation. All right, so let's clear a little clutter out of the way. And to make this a little bit easier to do the algebra and the calculus with, I'm going to rewrite this function like this, x cubed plus c x to the negative 2. Notice that all I did really was took the x squared that was in the denominator and moved it into the numerator. That's going to make it a little easier to take derivatives of. Okay, so how do we check to see that this is a solution? Well, the standard technique is to kind of take our value of y, okay, which is this, and substitute it into the left and the right-hand side of our differential equation and just see if we get the same thing. All right, so let's see, what's the left-hand side of our equation? It's xy prime. Okay, and the right-hand side is 5x cubed minus 2y. And the idea is just to take the thing that y is equal to and substitute it in both the left and the right-hand side. Okay, so here's y, and we'll just take it and substitute it in everywhere that we see a y. Once here, whoops. Okay, so they're substituting y into the left-hand side. And then once to the right-hand side, I just see one y there, and we'll take that y and replace it with a cx to the negative 2. Okay, and what we're going to try to do is confirm that we get the same thing on the left and the right-hand side. Okay, so starting with the left-hand side, we would like to take x and multiply it by the derivative of x cubed plus cx to the negative 2. If we take the derivative of that, we're going to get 3x squared plus c, and let's see, the derivative of x to the negative 2 is just negative x to the negative, or I'm sorry, negative 2x to the negative 3. Okay, and we've got a little algebra to do here, so let's see. I'm going to start inside the parentheses and rewrite that as 3x squared minus 2cx to the negative 3. Can we do anything else with that? Okay, I noticed one other thing we could do, and we could take that x and just distribute it through. Okay, let's do that. So x times 3x squared is 3x cubed minus 2c, and what do we get if we take an x and multiply it by x to the negative 3? Well, if you add the exponents, you're just going to get an x to the negative 2. Okay, so there's our left-hand side. All right, and moving down to the right-hand side now. Okay, there's no derivative to be taken. Looks like all we have to really do is some multiplication here. So we've got a 5x cubed, and if we distribute the minus 2 through, we're going to get negative 2x cubed for the first term, and then negative 2cx to the negative 2 for the second one. Can we simplify that expression at all? Well, notice those two terms are like terms, so we can subtract them, and we get 3x cubed minus 2cx to the negative 2. All right, and the question is, did we get the same thing for the left and the right-hand sides? We sure did. Okay, those two expressions are equal. Okay, and we have confirmed then that this family of functions is indeed a solution. Okay, so that is part A. So scrolling down, part B would like us to find a solution to the initial value problem, there's that word again, that looks like the differential equation that we just looked at together with the initial condition y of 1 equals 5. Okay, so remember again that most of the work is done. We already know that this function from part A is a solution to the differential equation part. Okay, so we already know that y equals x cubed plus c over x squared. We are given one additional piece of information, and that's this initial condition here. Okay, so the idea is just to use that initial condition to figure out what the value of this constant is. Okay, so we'll start with the given statement y of 1 equals 5. Okay, remember again, that's just giving us a point essentially. It's telling us that when x is equal to 1, y is equal to 5. So we'll take those two values for x and y and substitute in to the solution curve from part A that we already know. Okay, so if we let y be 5 and x be 1, okay, we're going to get that. And let's do the arithmetic here and see if we can figure out what c is. So 1 cubed is 1, c over 1 squared is just c over 1, which is c. Subtract 1 from both sides, and we can see that c is equal to 4. Okay, and so what is our answer to part B? Well, it's just the curve that we already knew as a solution with the value of c that we just calculated substituted in. Okay, so y equals x cubed plus c, which we now know as 4, over x squared. Okay, and so that answer is just the solution to the differential equation that happens to also satisfy that initial condition.